Yeah, we are looking at the integration by parts, and it's one of the methods for integration. And basically, integration by parts is useful for product of two functions. When you have a product of two functions, then you use integration by parts. Okay. Um, from the product rule, from UV, VDX of these two functions, where you use the functions of x, your v is the functions of x, is equal to v. We know that from product to dx, keep this constant, differentiate your du, then the one you are differentiating here, you keep it constant, then differentiate your v. Okay, then integrate both sides of the equation with respect to x. Integrate both sides uh, with, with respect to x. So if we integrate both sides of the equation, then this one will become uv equal to integral of v du dx, then plus integral of u dv dx. So what we are going to do now, we are going to make this one the subject, and that will be integral of u dv dx equal to, move this one to other side, move this function to other side. That will be uv minus integral of v du dx. Okay, so this is this uh, this is the use of first function, okay, and this one is what is your second function. Actually, this one, that's your question. U dv dx. That's your question. Then uv, and then vd. So we can just make this one, refer this one uv minus v du. Okay, so this will be using for our integration. So uv equal to v integral of v du. And what we are saying is that if this is a first function and this one is second function, then we can say the v dx is equal to a function. Yep, is equal to a function. Then we can get the v can now become what now? Integral of what? The function. Okay. Dx. We are going to see how I'm going to get my v. So just relax. Okay, let's see example on integration by parts. Yeah, integral of x e to the power 3x dx. So let's look at this question. Okay. If you look at this question, which one will be u? Which one will be um, the two of them are what? They are integrate. You can integrate the two functions. Okay, but x is more easier for differentiation. Okay, x is more easier for differentiation. Okay, in the sense that it becomes simpler on differentiation. This one becomes simpler. It's more easier to differentiate compared to this. So I'm going to call my u as what? As x. Then I need to get what? The u dx. The u, if we differentiate this one, that will be dx. Okay? Or it's not clear, the u dx, the derivative of this one is 1. So of course multiply. So you have the u, then you have the u equal to the dx. Okay, then the next thing is to get the second function. We said that your second function is what? The v dx. So the v dx is the second function which you can integrate, okay, which is equal to e3x, which will be equal to v equal to what? E3x dx. Okay, and we want to get v from that. So integrate the two sides, integrate this place, integrate this place. So v is equal to what? E3x. Then divide by this attachment to the variable 1 over 3. So we've gotten our v and we've gotten our what? Our u. Okay. Then we can now apply our formula, which is equal to what? Don't forget the question. I can use I to represent my question. Is equal to what? uv. My u is what? My u is x. My v is what? 1 over 3 e3x. Then minus integral of v 1 over 3 e3x. Then du. My du is equal to what? dx. Okay? And that will be equal to this one times this one, that will be equal to x over 3 e3x. Then minus this minus 3 can come outside the integration. Integral of this one of e exponential, that will be e3x, and then divide by 3 again, divide by 3 again, divide by 3 again, then plus c. So that's your answer. That's x over 3 e3x minus 1 over 9 e3x plus c. So that's that on that question. Okay, so you can see now this is your question. This is which I call I x e 3x dx. So this is your u, which is simpler. You can differentiate this one easily. Okay, and this will be your dv dx. Okay, which from there we got the v from that second function. You can see the v dx is what is one you can integrate. Okay, from there you can get your v from that place. Okay, and don't forget this formula I'm using for integration uv minus integral of v du. Okay, integral of s squared sin x. Okay, if you look at the formula, we said the first one is always your u, but it's not in all cases. The second one can also be your u, where the first one can be your dv and dx. Okay, so this is what we have now. It's more easy to differentiate this one. U is what? S squared. The u is equal to what? 2x dx. If you differentiate s squared, you get 2x. So our v now, our dv dx, or let me see, my dv dx or dv is sin x, dx. The v dx is equal to sin x. So by the time you put multiply, you have the v equal to this. Then you can integrate both sides. So v will be equal to what? Integral of sine is minus cos x. Okay? So it will be uv. This will go this way. It will be uv. Okay? Then minus integral of v. So uv, that is s squared cos x. The minus will be here. Then followed by, I didn't even write the symbol. Let me use I for the symbol. The question, which is I'm calling this one I. Okay? Minus that, then minus integral of v. My v is minus cos x. Then du. Du is what? 2x dx. Okay? So what can we do now? We can take that 2 out and this minus also out. So we have I equal to s squared cos x plus minus times minus. Then take the 2 out. Then you have x cos x dx. So what we are going to do now, this also is a product of two functions. This is x times this. So we are going to repeat the integration again, whereby this one will be much simpler for differentiation. So we are going to have u is x and the u is equal to what? Dx. Then the v will be equal to what? Cos x dx. And that will be equal to v. If you integrate both sides, you have v equal to what? Sin x. So that's my v. So I can use my formula. Don't forget the formula. And that will be equal to I equal to x minus s squared cos x. Then plus 2, open brackets, uv. This one will multiply this one together. That will be, the u is x My v is what? Sin x. Then minus integral of v sin x, integral of v sin x, and then times du. Du is what? Dx. So you can close your brackets. You can close your brackets. Okay. And don't forget the formula we are using. We're using uv minus integral of v du. So that's what I'm using here for integration by parts. So then the next thing we can do now is to open the brackets, minus x squared cos x plus this one times this one. That's what? That's 2x sin x. Okay. And then this one times this one, that's minus 2. Integral of sine is minus cos x. So this one becomes plus. Then what's plus? Integral of x to the power 3 log of x is e dx. So this is what we have. This is what we have. Then you can see what we are talking about. That is not all cases that the u, that the first function will be u. If you check this one now, there is no based on what we said initially, that don't forget what we said, that will be u, the v, dx. That's the question. That the second function must be function that be what? That is you can integrate it. Okay. But in this case now, this second function, you cannot integrate it. So it will be much better for us to what? We don't even have an option. This must be u, because we can easily differentiate this. There is no table for what? Log x base e for integration. So we'll call this one our u, then we'll call this one our dv dx. So that's what we're going to do in that question. Okay. So my u now is log x base e. That's my u. Then I can get my du, which is equal to what? If you differentiate logarithm to base e, it will be the derivative of this, which is 1 over the function itself, dx. So that's my du dx. Then I can get my dv. My dv is what? S3 dx. Then you can integrate both sides. Then you can have v equal to what? X power 4 over 4. Then you can get your uv. You get your uv, then minus integral of your v. So that will be equal to, my u is that'll be x4 over 4 logarithm to this e, then minus integral of v x4 over 4, then du dot 1 over x dx. Okay, so we're going to have now x4. I didn't even indicate, just started. This is, I call the question, let me call this question I. Okay, so I is equal to that. I is equal to, okay, x4 over 4 log to base e, then minus integral of this one will go here to remain f3 here, and 1 over 4 can be outside the integration, then dx. So then we have what? x4 over 4 log to base e of the function, then minus 1 over 4. The integral of this will be x4 over 4 plus c. So then you can multiply. So this is 1 over 16 x4. Okay, 16. So that's that. Integral of x arctan x, inverse function of target. Let's see how. Yeah, if you look at this also, this will be u in this case, because it will be it is easier to differentiate the arc function. We cannot integrate this. Okay, arctan x. Okay, we can integrate that, but it's more complicated. So I think it's more better to call this one u. It's more better to call this one u. Okay, it's more better to call this as u. You can integrate it. You can integrate it, but let's call it u. Let's do this one u, and let's do this one our dv. So u is what? U is the arctan what? Arctan x. So the u is what? The u is 1 over 1 plus x squared dx. Okay. Then my v is x and integrate both sides. So that will be equal to what? S squared over 2. Okay. Then this my question is I. So I don't want to call it I. You can write your question again. Integral of x arctan x dx is equal to uv. The u is x2 over 2 arctan x, then minus integral of v x squared over 2, okay, times the u, which is 1 over 1 plus s squared dx. Okay. So, and that will give us s2 over 2 over arctan x minus this half can go outside. Then we have s2 over 1 plus s squared dx. So, and you can see this this fraction, the degree of s of the numerator and denominator is the same. So I will need to take it out before I can integrate. So of course, we can't go further in this place. So when your degree of numerator and denominator is equal, then you carry out polynomial division. So that will be equal to what? S squared plus 0x. Okay, then plus 0. That's say power 2, power 1, and power the constants divided by what? 1 plus. Let's make it s2 plus 1. Okay, so what can we use to multiply s2 so that we can get the first item here, s squared? We can use 1. So 1 times s squared, this s power 2, and then plus what? Plus. We don't have this is 0 plus 1. So you can subtract, then we have this will be 0. Okay, and this will be equal to what? 0 minus 1, that's minus 1. We have there. Okay, I want to finish. I'm solving this one alone. S2 over what? Over 1 plus s squared dx. So which will be equal to integral of the quotient, which is 1, then minus 1 over the we have here 1 plus what? 1 plus s squared. Close it. Okay. So that's that. So this will give us x minus arctan what? Arctan x. The integral of this is arctan x. That's a table for that. So we can go back to final answer. We can now say our question: integral of x arctan x dx is equal to, what do we get? We have x2 over 2 arctan x, then minus half into brackets this one, which is x minus arctan x, close the bracket. Then you can expand. If you expand, that'll be plus c. They will put plus c there. So if you expand, you have s2 over 2 arctan minus x minus, you can open your bracket, x over 2 plus arctan x plus c. So that's that on that. That's that. I want you to see something. If you've gone for this arctan x and you call this one the v you go to arctan x. So we don't have the integral for this. Just wasting your time. So this will be what? Differentiable function. Yeah, this will be differentiable function. Yeah, it's not you can't integrate that. Okay, so that's that.